Hey AP Psych friends, we are in video 2 of Unit 3, Biological Basis of Behavior, still talking about the nervous system and the endocrine system. Let's take a look here. We are done with the basics with neurons, neurotransmitters. Let's put it all together. And so when we talk about the nervous system, we can talk about a few things. The first here is that we can divide the nervous system up into two components. CNS is just going to be our abbreviation for central nervous system. And the biggest mistake seems to be that AP Psych students, being the smart people you are, read too much into this. Central nervous system equals brain and spinal cord. That's it. Don't fall for any tricks concerning test questions trying to make you think it's more than just that. But, I mean, obviously the brain and spinal cord do a lot of important functions. Neural networks, listed there as the first bullet under CNS. Just know that the neurons are going to operate together to form complex functions. And so if you remember in class we were discussing this, that nerves in our body are actually bundles of axons of a plethora of neurons all working together to complete a complex task. Concerning neural networks, we can also talk about nuclei. These would just be collections of nerve cell bodies in the CNS. And so we can look at them that way. We can look at them from the perspective of fiber tracks or pathways, and those are just going to be, again, those axons in the central nervous system that are traveling together in bundles. Okay, so you can have collections of the cell bodies together, you can have the axons traveling together in bundles to give you a neural network. So the brain, stay tuned, that's Unit 3B where we will talk about the brain, but that is a component of the central nervous system. A pretty big one, it gets its own section of the unit. The spinal cord, though, is the second component of the central nervous system. So let's chat about that for a second. Your spinal cord actually does a lot of tasks to kind of leave your brain free to do higher order thinking things. And so things like reflexes or simple automatic responses don't really have a need to travel all the way to the brain, in that the spinal cord can handle the function on its own. And so you're putting your hand on that hot stove burner. That message, those sensory neurons taking that information to the central nervous system, it goes no further than the spinal cord. That is why your hand is off the stove burner before you've consciously processed. Again, that's occurring in the brain before you've consciously processed that you even burnt your hand. Okay, and so when we're talking about things within the spinal cord, we have two new words regarding neurons, afferent and efferent. This is really easy. Afferent is just a fancy name for the sensory neurons in the spinal cord, and efferent is a fancy term for the motor neurons in the spinal cord. Okay, and so afferent, right? Remember, sensory, taking the information in. So think afferent approach. That's how I remember that those are the sensory ones. And I always think of efferent as exit or going away. So hopefully that will help you with those special spinal cord specific type of neurons. Okay, so all neurons not involved in the brain and spinal cord are part of your PNS or peripheral nervous system, right? Think peripheral, to the side of. And so the peripheral nervous system is going to connect the rest of the body to the central nervous system. It can be divided up into two parts, somatic and autonomic. The somatic, soma, Latin for body, is going to just affect skeletal muscles and movement, right? And so think of these as conscious movements of your body as being somatic. The autonomic, this is easy to remember. Think automatic, right? These are internal glands, muscles like the heart, things that you don't normally have to necessarily be aware of as functioning in the body are probably communicating with the brain using the autonomic nervous system. Okay, now what's fun is that the autonomic nervous system can be divided again into two parts. The sympathetic nervous system is going to be the part of the autonomic nervous system that arouses and mobilizes the body. Think fight or flight when you think sympathetic nervous system. And parasympathetic nervous system calms the body back down after an action. Okay, my favorite analogy or story to use is this. You're driving home from school and you pass a police officer. Even if you are not guilty of any wrongdoing, I am guessing that your heart rate increases slightly and that your foot has stepped on the brake before you've even consciously registered whether or not you were speeding. It's the sight of the police officer that alerts you to an issue, and your body is reacting to that before you've even had time to consciously process it. Those of you that had me in regular psych remember the day that I screamed at you. I won't do that to my AP friends, but if I were to scream at you, even if I told you, hey, I'm about to scream at you, you're still going to jump and react. That's that fight or flight. And then once you realize, silly Daly, why are you screaming at us? Your parasympathetic nervous system would calm you down after that rather stressful event. Okay. The endocrine system. Know that we are not going to spend a lot of time on this, simply because I'm hoping between health class and biology class that you know enough to get you by. They're not going to ask you a whole lot of questions about the endocrine system. They may ask you about hormones and target organs, so we'll talk about those briefly. First of all, know that the endocrine system is your body's chemical communication, no different than the chemical communication happening with neurons. However, endocrine system uses hormones that travel in your bloodstream, which means that this is your body's slow chemical communication. Okay, and so chemical communication that needs to be more long-term, but doesn't necessarily have to be immediate, will be happening through the endocrine system. It's kind of like texting versus mailing somebody a note. The nervous system is very quick to react, but the endocrine system can still get the same message there, just not in the same amount of time. All right, so our hormones are our chemical messengers. They're made by glands. Many of these are similar to neurotransmitters, and some of them are the exact same chemical as the neurotransmitters that exist in our nervous system. The only difference is where it's made and how it travels through the body. So more specifics as we practice that in class. Target organs are going to be the organs that have receptors on them for specific hormones. So an example of this is your pancreas is the gland, right, that releases insulin. And there are receptor sites on your stomach that as the insulin, right, is traveling through the bloodstream, the stomach knows that it is the organ that needs to absorb that. And so that's how, roughly and simplistically the endocrine system works. The only, in past experiences with review books and past tests, it seems to be that they just focus on two main parts of the endocrine system. So we're just going to focus our energies here. It seems to be that they like to talk about the adrenal glands, right, which actually exist above your kidneys. And the easy way to think of this is your adrenal glands, think adrenaline. Okay, and so the adrenal glands will pop up in the unit where we deal with stress and health, in that the adrenal glands are going to be activated in prolonged periods of stress, and they can actually, prolonged use of adrenaline in the body can actually lead to stress and exhaustion and some physical side effects. And so we'll apply that when we get to that chapter. The one that's big just in Unit 3 in and of itself is the pituitary gland, which we will label on our diagram of the brain in class. But the pituitary gland is actually located in the brain, but it is a gland. The part of the brain that is in charge of talking to the pituitary gland is the hypothalamus. So we'll do more of that in the brain section. But the hypothalamus is kind of the translator between the nervous system form of communication in the brain and the hormonal system of communication that's used in the endocrine system. And so the pituitary gland is going to take its cues from the hypothalamus, right? That is the upper management within the brain. And then the pituitary gland is the boss of the entire endocrine system. It in turn interprets what the hypothalamus and the brain as a whole need from the endocrine system and sends hormones through the bloodstream to alert whichever glands need to start working to get them to work. Okay. Additionally, the pituitary gland also is in charge of regulating our growth, and so we can talk about that as an added piece of information they sometimes quiz you on. An example of something within the pituitary gland that sometimes is mentioned as well is ACTH. That's an adrenocorticotropic hormone. Easy to say. But this is how fight or flight works, okay? And so the pituitary gland sends ACTH to the adrenal gland in a time of stress, and then the adrenal gland lets out cortisol, which is actually a type of hormonal steroid, which will activate that sympathetic nervous system. And so I didn't mean to diss on the endocrine system as that, it's just slow communication, because endocrine and nervous system are constantly in communication with each other and really do affect one another's workings. All right, so more practice with that when we get to class. All right, the final thing to mention here in video number 2 for Unit 3 is the immune system. Not a whole lot gets mentioned in the actual Unit 3 types of questions. Again, more to come when we get to the unit on stress and health. But know that the immune system kind of serves both as a sensory and a security system for the body, because it's our defense against foreign invaders or foreign substances. And so it's going to work with both the nervous system and the endocrine system, which is why it deserves at least a tiny mention here. Additionally, we mentioned this in class, I believe. Autoimmune disorders can be physical problems that are caused when cells of our immune system actually attack normal cells in our body as if they were invaders. And so one of the examples, right, is multiple sclerosis, or MS, in which the person's own immune system is destroying those glial cells, or those helper cells that allow the myelin sheath to form with our neurons. And so that's why MS patients have trouble with movement, and eventually once it's in a very chronic or acute case of MS, you're going to have issues with thinking and remembering, and then eventually automatic functionings like breathing and heart rate, sadly. And so there it is. That's the stepping out from these very specifics of the neuron, taking a step back and looking at the nervous system as a whole. The next section, Unit 3B, we're going to dive right into that part of the central nervous system we kind of glossed over in this video, and that's the brain. And there's a lot of stuff to talk about there, so take a break. Thank you so much for listening.